Why did Australia build the longest trucks on Earth instead of relying on rail or conventional freight systems? Deep in the Northern Territory, multi-trailer road trains stretching over 50 meters thunder across empty landscapes, carrying fuel, livestock, and critical supplies to settlements hundreds of kilometers apart. These trucks are not a spectacle. They are a necessity shaped by distance, cost, and isolation. And the story of how they came to exist begins with camels. In the heart of the Australian outback, every delivery was a test of endurance. Before engines arrived, camel teams and horse-drawn drays were the only way to move goods between far-flung stations. Camels, brought to Australia in the 1860s, could cross the desert where horses failed, but even they had strict limits. Each animal needed water every few days, and the heat often forced caravans to travel at night or rest for hours under sparse shade. The payload was always restricted. Most camel teams could manage only a few tons at best. The terrain itself added to the strain. Loose sand, rocky rises, and dry creek beds slowed progress to a crawl. A journey from Oodnadatta to Alice Springs could take weeks, with every extra barrel of water or bag of flour making the load heavier and the pace slower. Horses struggled even more, their need for water and feed making long hauls nearly impossible across the central deserts. As the wool and cattle industries grew in the early 20th century, the gap between what the land demanded and what animal teams could deliver became impossible to ignore. Isolated stations faced shortages, delayed shipments, and high costs. The outback's sheer distances and brutal climate pressed relentlessly against the limits of muscle and patience. The old ways had reached their breaking point, and the search for a new solution became urgent. For more stories about the hidden systems that keep our world running, subscribe now and join us as we uncover the engineering behind everyday life. Kurt Johansson was not an engineer by training, but necessity turned him into one. In 1934, working outside Alice Springs, he built a machine that would change outback freight forever. Instead of relying on a single trailer, Johansson fitted a modified International Harvester truck with a turntable coupling, a steel disc that allowed a trailer to pivot freely behind the vehicle. This simple yet radical idea let him add a second, then a third trailer, each connected by a system that could flex and twist over the harsh terrain. The result was a convoy that could snake through sand drifts and creek beds without breaking apart. Johansson's design was more than improvisation. He filed a patent AU 1933624 in 1936. Detailing the turntable mechanism that would become the blueprint for future road trains. The modular trailer frames could be built from scrap steel, assembled on site, and extended or shortened as needed. Oral histories recall Johansson's pride in loading a full mob of cattle in one go, a feat that cut travel times by up to 60% compared to camel or horse teams. Stations that once waited weeks for supplies could now receive deliveries in days, even as the old tracks twisted through the desert. Photographs taken by Johansson's son Otto show the early rigs, battered and dust-caked, but unmistakably modern in their ambition. The invention was not about building the world's longest truck for its own sake. It was about solving the problem of distance with a machine that could be repaired, extended, and trusted to deliver, no matter how far the next station lay beyond the horizon. A road train's efficiency begins with how it spreads its weight. Instead of a single, rigid unit, each trailer connects through a pivoting dolly, essentially a mobile hinge with its own axles. This articulation lets the train flex and snake over uneven ground, but the real advantage lies in how it distributes load. Every axle carries only a fraction of the total weight, keeping the pressure on each wheel low enough to prevent the road from breaking apart, even under a 200-ton load. The design means that a single prime mover can pull 3 or more trailers with far less stress per axle than would be possible if the same tonnage were packed onto a single shorter truck. For the operator, this translates to a dramatic reduction in labor. One driver working a legal shift can move the same volume as 3 separate trucks, cutting both wage costs and the number of vehicles needed for a 1,000-kilometer run. The result is a freight system that turns the outback's vast emptiness from a barrier into an advantage, maximizing payload, minimizing wear, and making every drop of diesel count. Designing a freight corridor for the world's longest trucks is an engineering challenge shaped by extremes. On the Stewart and Barclay highways, the pavement must bear repeated loads from vehicles weighing up to 210 tons. Engineers layer the roadbed with a granular base up to 30 centimeters deep, topped by polymer modified bitumen that resists rutting under relentless axle pressure. Curves are widened to a 45-meter radius, and turning basins at key roadhouses stretch 12 meters wider than standard, allowing a 53.5-meter road train to swing through without cutting corners or damaging the verge. Bridges, once designed for lighter traffic, have been retrofitted with high-strength steel decks and post-tensioned girders. The crossing at the Ord River on the Victoria Highway now supports the full legal mass of a triple road train, 210 tons, thanks to a composite steel concrete system installed in 2022. LC Bridge on the Stewart Highway underwent similar reinforcement. These upgrades are not one-offs. A 4-year resurfacing cycle keeps the main corridors within safety margins, monitored by real-time axle load sensors that flag any vehicle exceeding the limit. Every kilometer of upgraded corridor is a silent negotiation between scale and survival. The result is a network that quietly enables the movement of goods across distances that would defeat lesser roads, making the outback supply chain possible. Railways often seem like the obvious answer for moving freight across vast distances. In Australia's interior, though, the numbers tell a different story. Building a single kilometer of standard gauge rail across the outback can cost upwards of 10 million Australian dollars. The terrain is unforgiving. Rocky ridges, floodplains, and shifting sand demand constant engineering and maintenance, yet the freight volumes simply aren't there. Population density in much of the interior drops below 1 person per 10 square kilometers, and most mines, cattle stations, and settlements are scattered hundreds of kilometers apart. Even the largest seasonal surges, moving cattle before the wet or hauling fuel to remote communities, fall far short of the daily tonnage needed to justify the investment in new rail lines. Instead, governments and industry have chosen to improve roads, which can be upgraded in stages as demand grows. A reinforced 2-kilometer stretch of highway costs a fraction of a comparable rail spur and serves not just freight, but every vehicle on the route. Road trains, with their flexible routing and ability to adapt to shifting demand, solve the problem of sparse, unpredictable freight flows. Their efficiency only grows as distances increase and traffic thins out. For the outback, rail remains a solution waiting for a problem big enough to pay its way. A problem that, for now, simply doesn't exist. Bringing a 53-meter road train to a halt is nothing like stopping an ordinary truck. On dry pavement, a fully loaded rig traveling at highway speed can require more than 600 meters to stop, nearly the length of 6 football fields. For this reason, every driver must hold a heavy combination license with a special road train endorsement, earned only after advanced training in multi-trailer handling and emergency braking. Annual renewal is mandatory, with regular medical checks and competency assessments enforced by the National Heavy Vehicle Regulator. Permits are not handed out lightly. Each year, thousands of applications are reviewed, but only a small number of breaches are recorded, most for minor overloading or route deviations. The system's integrity relies on strict compliance. A single mistake can put hundreds of tons and dozens of lives at risk. On routes where sight lines are limited or traffic is dense, pilot vehicles travel ahead, equipped with warning lights and two-way radios to coordinate overtaking and alert oncoming traffic. These pilot protocols, combined with corridor-specific signage and electronic monitoring, make it possible to operate the world's longest trucks safely across some of the most unforgiving terrain on Earth. Every kilometer is governed by rules designed to match the scale of the machines and the consequences of getting it wrong. Remote communities across the outback depend on deliveries that arrive not by chance, but by the precise timing of road trains covering hundreds of kilometers. For these residents, a missed shipment can mean empty shelves, delayed medicines, or stalled mining operations. The system's scale offers an environmental trade-off. A fully loaded road train emits around 0.37 kilograms of CO2 per ton kilometer, lower than the combined emissions of 3 smaller trucks making separate trips. This efficiency comes from consolidating freight, reducing the number of engines running, and maximizing every liter of diesel burned. Yet the push for zero-emission transport runs up against hard limits. Battery-powered trucks face steep challenges in the outback. With current technology, a battery pack heavy enough to power a 90-ton train might only last 250 kilometers before needing a recharge, far short of the 1,000-kilometer journeys required. Each additional ton of battery weight means less payload, and with only a handful of charging stations scattered across the Northern Territory, diesel remains the only reliable option. Hydrogen prototypes promise longer range, but infrastructure is almost non-existent, and high temperatures sap battery performance. Communities rely on the certainty that a road train will arrive, rain or shine, on a set schedule. The system's efficiency is measured not just in emissions, but in the lived reality of people who need food, fuel, and medicine delivered across vast distances. For now, the road train is the best fit compromise, more carbon efficient than smaller trucks, flexible enough to meet the needs of scattered settlements, and robust in the face of technological limits that keep zero-emission freight just out of reach. Today, a single road train can move what would take 4 or 5 conventional trucks. It bridges distances that defeat rail and defy easy solutions. As global supply chains strain under new pressures, Australia's outback logistics remind us, real efficiency is born from necessity, not spectacle. Subscribe for more hidden infrastructure stories.